The first one who will be presenting here now, this late afternoon, is my colleague from the US, Aaron Frankel, and he will tell you about which benefits digitalization can bring in the additive manufacturing industry. So welcome up on stage, Aaron Frankel.
Thank you. Thank you, everybody, for joining us today. We've got a full house. It's exciting to be here. So today, we're going to talk about additive manufacturing. And here at Siemens, we believe in creating new ways to design and produce products. And we do this by combining the power of additive manufacturing and digitalization to give us that ability to take an idea in our heads and transform it into a digital model that we can then inexpensively manipulate, optimize until it's perfect, and then turn it into atoms. And we do this with 3D printing. I think I might need my clicker. But in order to unleash the power of additive manufacturing, it's absolutely important for us to change the way we think about designs. And this gives us the power to reimagine products and start to unleash new capabilities. It gives us the ability to transform our designs around the functional capabilities of the products. What you're looking at here is a high temperature burner, and you can see a very complicated shape. The purpose of this burner is to essentially burn messy fuels at an extremely hot temperature to extract the hydrogen. But you have to burn it so hot that you can actually melt the metal of this burning tip. So our engineers optimize this design using advanced computer-aided engineering capabilities to be able to create a shape that will stay cool while executing this process of fuel refinement. Another way where we can take advantage of additive manufacturing is to optimize our designs for performance. And in this particular example, we're looking at a lever from an aerospace example. This lever is actually at the tail of the aircraft. It's used to connect the actuation of the pilot's joystick to the elevators on the back to control its pitch. And what we've done here is we've leveraged generative design capabilities where we, as a designer, tell the system what kind of performance we're looking to get out of this design, and then let this computer generate an optimized shape to achieve those goals. And the computer came up with a very interesting shape that's not only just as strong as the conventionally manufactured part, which is cut out of a block of metal, but is 15% lighter. Now, you couldn't make this geometry using conventional methods. Additive manufacturing unlocks this power. Another example of the way we have to change the way we think about additive manufacturing is to think about designing individualized components, components that are mass customized. And the reason why additive manufacturing is important in this area because it gives us an economical way of being able to produce these types of parts. We don't have to invest in expensive tooling in order to create very complicated shapes. We can turn our designs directly into atoms. But not only do we need to change the way we think about designing these parts, we need to begin to incorporate the additive manufacturing technologies into our production environment. We need to retool our manufacturing. And there's some interesting technologies that Siemens believes the industry can use to deliver completely new types of product designs. And those technologies are listed here. And I'd like to kind of run through a couple of examples for you. This first part was created using the Powderbed Fusion capability. Essentially what it does is you take a very fine laser beam and control it to melt a very fine powder and grow the part in one direction. And what's interesting about this technology is that it lets you create very intricate details that you would not be able to make using conventional approaches. Notice all the very fine detail on the interior of this part. This is that gas burner that I talked about earlier. And in fact, this design was optimized around, was actually created with inspiration from a vegetable, from fennel, from a fennel bulb, was used to do this. So you couldn't make this using conventional approaches. Another technology that we find very interesting that we're focusing on is called jetting. And jetting essentially is a technology that HP is pioneering to be able to take a chemical agent and drop it on material powder and then use heat and light to solidify that material into a shape. And what's interesting about this technology is it was used to create this gear and essentially allows us to scale up volume production of printed parts to the point where it's becoming economical to produce high volumes of pieces. HP's calculated that with their first version of this printer, they're able to print 55,000 of these gears as economically as you would using an injection molding process, which I think is quite impressive. Another technology is directed energy deposition. This is where you take a nozzle that's equipped with the ability to blow metal powder and then sinter the metal powder using a laser beam equipped to that nozzle. And what's interesting about this capability is it allows us to unlock the ability to use a combination of manufacturing technologies on a same machine. We call it hybrid manufacturing, but essentially the ability to do additive manufacturing as well as CNC machining on the same machine tool. DMG Mori is pioneering this approach, and we've partnered with DMG Mori to be able to unlock its capability. So this is stainless steel that has been 3D printed, and you can see this very mirror-like area where a CNC cutting tool was used to machine it to a high surface finish and tolerance all on the same machine. And then last, I'd like to show you an example of material extrusion. This is essentially a composite part that was printed using a material extrusion head connected to a robot controlled by a Siemens controller. And what we've done here is we've automated the ability to produce composite parts. And because we've done it on a robot, we're able to take 3D printing out of the small box or print volume we normally make parts and begin to scale it in size, where we can begin to print very large parts. And this is significant because these composite parts can replace metal parts, and they're much lighter. So after we're able to kind of change our mindset and begin to design parts for additive manufacturing, and we're able to take advantage of these types of technologies in the production environment, we can begin to rethink our business. And this gives us the opportunity to, say, print on demand, create parts on demand. We no longer have to rely on mass production, but we can print exactly what we need, exactly where we need it. And this enables us to unlock the power of, say, digital inventory. We no longer have to store a large inventory of physical parts. not only can we individualize and customize, but when we start to take advantage of additive manufacturing, we can accelerate our innovation cycles because we no longer depend on long lead tooling items, castings, for example, or injection molds. We can produce exactly what we need when we need it. But in order to take advantage of these capabilities in an industrial environment, we need to have the right tools. And the problem is that many of today's tools and systems that would be used to create these parts are disconnected. There's a disconnected software chain and a disconnected hardware chain. And when you have disconnects, you start to lose control of the workflow. You have to convert data and information between the different applications. And this is what can prevent us from taking this technology into the production environment. And so our big idea is to add tools to the digital enterprise suite to help us industrialize additive manufacturing. What we're doing is in the PLM environment, we've added new design tools to enable designers to create very organic, topology optimized shapes that are lighter in weight and just as strong. We've added the ability to be able to simulate these designs so we know exactly how they're going to perform after we make them. We also are adding tools to be able to simulate how the production or the printing process is going to work. So now when we create our plan to be able to print them, we know that we'll achieve the desired geometry we're looking to get. And we've added the tools to be able to design the print preparation process, to be able to deliver the work instructions or the instructions and the data to the machines in order to create these parts. But we also need integrated tools and equipment on the production side, which is why we're investing in our totally integrated automation portfolio to be able to connect hardware for 3D printing directly into our mainstream production environment. We have the automation, the drive capability to be able to drive the individual machines by providing these pieces of equipment into the control cabinet. And we're able to connect these machines into our production environment, so we're able to deliver information to the machine, pull information off of the machine, and use that to optimize our design and our engineering processes. And then lastly, you need to be able to control production. You need to be able to manage your orders, manage your schedule. And our manufacturing operations management suite delivers these capabilities. So I'd just like to end on, we recognize that we're embarking into a new frontier with additive manufacturing. There's a lot to learn. And in order to be successful and to industrialize this capability, companies need to be able to work together in an ecosystem and share information, share knowledge and expertise. And so what we've built, or we're building, is a platform for part manufacturing where we can connect together people who have designs that they would like to optimize for 3D printing with experts that have know-how to be able to help design those parts, with machine tool OEMs and printer OEM companies who can provide guidance on how to best unlock the capabilities of their systems, with institutes, communities of engineers, and co-innovate together. So with that, if you have any questions or would like to see some more examples and see some of the software in action, I would welcome you to come take a look over here at our additive manufacturing cube, and we'd be happy to talk with you more about it. Thank you for joining us today. Please don't step on each other on your way out. I know it's going to be kind of crowded. Just be careful when you go down the steps. But anyways, thank you all for attending. I appreciate it.